Okay, so I'm, I'm Henrique, I work at Protocol Labs, and I'm here to bring you a bit of the decentralized web and IPFS. But first of all, why does all of this matter to you? Why should you care about the decentralized web? Let's take a look at some cases. 2 years ago, during Catalonia's referendum for independence, there were many reports of websites about this subject being blocked through DNS tampering or HTTP blocking by the central Spanish government. This is clearly a really big violation of freedom of speech and freedom of thought, and it might even have affected the results of the referendum. There's another interesting case. Wikipedia is probably one of the richest, if not the richest, internet resource that should be available for everyone, independently of who they are or wherever they are. It has been around since 2001, and it has a lot of information, media about every single thing you can even imagine. Here is a simulation of how big, how many books it would take to save English Wikipedia's text, and only its text. It's about 2,608 volumes, which is really huge. However, since April 2017, it has been blocked in Turkey. I don't know if you knew that. Turkish authorities blocked an entire nation the access to the world's biggest, freest, and most powerful wiki on Earth, just because there is an article on English Wikipedia, or there was, I'm not sure, that described Turkey as a sponsor country for ISIS and Al-Qaeda. And Turkish courts view this as a public manipulation of mass media. If you go to Turkish Wikipedia right now, where it should be read, the free encyclopedia, you can now see we've been missing you for 2 years, which is really sad and unfortunate for everyone that is living there. A much more recent case dates to only a few days ago. Beginning on November 17th, in response to Iranian fuel protests, an internet shutdown reduced internet traffic to as low as 5% of the normal levels. We can already see some places being reactivated again, but this only shows the power that governments and central authorities, ISPs, have over our internet and our access to information. Although this is the first time it is happening on Iran, it's estimated that over 60% of the internet bandwidth in Iran is spent using Telegram, the messaging app, and Telegram has over 50 million Iranian users, which is a lot of people, more than Portugal's population. Temporary blockages of this service have happened over and over again during protests, so people couldn't communicate in that country. As you can see, there is a really impactful issue with the internet nowadays, totally centralized, relying on central authorities that decide what we should or not be able to see. There's actually a list of about 90 websites blocked in Portugal. I don't know if you knew that, but even though we don't notice that as much, it's actually happening in Portugal. So, what if there was a better way? Actually, we are in 2019, 50 years after the creation of the internet, and there are alternatives that are being worked on, and I believe we are moving towards a better direction. Let's look at OrbitChat. OrbitChat is a completely decentralized online chat that does not require centralized service to work. Orbit is built on top of IPFS, the interplanetary file system, and it works on a distributed network. But why should you care about that? What is a distributed network? On a centralized world, such as with WhatsApp, Telegram, Messenger, we require constant connection to the server, to a central point, so everything works. Let's see this example where Mary is entering labor, and she wants to tell her husband, John, that she's going to the hospital because, well, he may want to be there. However, and give her support eventually. However, her connection to the server fails, and, well, John won't be able to go to the hospital because he doesn't know. And there might even exist some network path to John, but since we are relying on a central server to make everything work, she can deliver the message to John. Or maybe the server itself has some problems and no one can use the service. It has been happening a lot lately with Instagram and Facebook. No one knows why. Unfortunately, John won't be able to witness the birth of his first child in this case. However, on a decentralized network, where everyone can be connected to everyone, they don't need to, but they can. If there is a connection problem with the connection between Mary and John, it's not a real big problem because there are so many routes to get information from one point to another that it will be solved within milliseconds. And this is one of the most important advantages of decentralized networks. We don't rely on central services and central points of failure that might fail at any moment without us knowing. This way, John would have been able to witness the birth of his first child, and he would be certainly very much happy. So, in a decentralized application, everyone is equally important because everyone has a role to play, and thus it is much harder, if not impossible, to shut down a service like this one. And this does not only apply for the messages that are sent between people. Even the application itself can be loaded from someone else and not from a server somewhere where the application can be hosted. Let's take a look at a different application. This does not look as it looks. This is what's supposed to, but this is called Textile Photos. It's a decentralized Instagram-like application where you can share your pictures, thoughts, without storing them in a data center somewhere in the world where only a big company has access to. This application lets you create groups, you can share with your friends, or you can even just keep them private as a private album if you want. This application is built with Textile, which is a library built on top of IPFS and adds authentication, security, just to name a few features. As they say, it's an open and programmable iCloud. However, it is built on the decentralized web and not on the centralized web. Let's take a look at a quick demo. I'm just showing you this demo so you can see that even if you're not, and there's me, even if you're not following the classic server-client model, the application doesn't need to be difficult to use. It can be just as uncluttered and simple to use as this one. And yes, there's the monkey. And some comment going on. This is really slow. Yes, he almost. Okay. Let's take a look at another application. This is IPFS Desktop, which is the official IPFS client that can be used as a kind of Dropbox. You can just drag and drop a file there, and you will have a link you can share with someone else. But you might be asking yourself, what is that link, and what does it even mean? So let's take a look at this link to a white-faced monkey. Let's break it into different parts. First and foremost, we have the gateway URL, which is part of the functionality provided by IPFS, which kind of translates the an HTTP request to an IPFS request. It is useful nowadays, so present-day browsers can easily see IPFS content. Maybe in the future, hopefully in the future, instead of seeing HTTP / and HTTPS // we'll start seeing some URLs like this one. However, let's not focus on that. Let's focus on the second part, the mix of digits and letters. That is what is called a CID, Content Identifier. The CID is a unique profile, it is cryptographically generated, and no two different files can have the same one. The web we know nowadays is content location addressed. So, for example, when you go to google.com, you're just accessing some domain name system server and translating that name to an IP address which corresponds to some machine somewhere in the world. So we are just saying we want to access Google servers. But IPFS is content addressed. So you say what you want and not where you want to get it from. Another interesting application of IPFS is to publish websites. Here is a demo of IPFS Deploy, which is a really small tool that helps publishing sites on the IPFS network. And I actually use it on an automated process to update an XQCD clone I maintain. And it runs every day, and it have had no problems since the day one. And you can even access it using normal HTTP. You just need to replace IPNS for HTTP, or you can use this QR code here. I even use it on my own website. These are, of course, just 3 apps on a universe of many of them. There are more and more apps emerging every day using IPFS or other decentralized technologies. And such as DTube, some of the most used ones are, for example, DTube, Everypedia, and BitTube, which the first one is one of the most known, and it's an alternative to YouTube. It's an endless world of possibilities, and you can build your own application. But how how all of these work. You already know that IPFS relies on this decentralized network and it is content addressed, but how does all of this come together? And so the interplanetary file system, also known as IPFS, is not only decentralized but also distributed in the sense where everyone, plays a role. We can also say that I need to get some water. We can also say that a decentralized network is just a small subset of a distributed network. As mentioned before, IPFS is also content addressed, so each file, each combination of bytes has its own CID, which is also always the same size. And it is also important to mention that whenever you add a file to IPFS, it is chunked into smaller bits, and each one of those smaller parts has its own CID, and the big picture, the big file, is just a pointer to all of those blocks that constitute itself. Since IPFS is also peer-to-peer, where all peers are equally important, you can just ask the network. For example, here Bob is asking for the kmesh file, which is a file divided into 4 different blocks. You can just ask the network for all of those blocks, and they will be sent to him, and we'll get a beautiful picture of a white monkey. This also means that every time you get something, it is in a certain way cached in your computer and your IPFS node, so it can be really useful, for example, to see websites offline, or, for example, I'm pretty sure this has happened a lot of times to you when you don't have internet and you have a tab open to read later, and then you click refresh, and then, poof, it just disappeared. With this kind of networks, even though you might have the content on your computer, with this kind of network, it will just get the content from your own computer, and there wouldn't be any problem at all. To add on top of the file being chunked, IPFS also relies on a Merkle tree. In this case, a giant forest. A Merkle tree is just a hash, also known as a hash tree, where every non-leaf node is labeled with a hash of a content data block, and every leaf node, I'm saying this is the opposite, sorry. Every leaf node is labeled with a hash of a data block, and every non-leaf node is just a hash of the hashes of its children. Also, for finding contents, we rely on a distributed hash table, aka DHT, which is just a giant hash table distributed across many peers all over the network, and anyone can look up for the contents of some hash. On top of all of how it works, IPFS is also censorship-proof in the way that it's much harder to block the access to some content, because it's not as easy, if not impossible, as it would be to just block the access to a certain domain name. It's also permanent in the way that as soon as you have the CID for something, it just needs one person to be hosting it for you to be able to access it. And however, if many people are hosting it, it would be much harder to just throw away some content. It also provides duplication, since every file is divided into multiple blocks. If the blocks are the same between some files, they will be deduplicated, and you can save a lot of space. And it's also resilient and offline first. So, if you want to learn more, you can go to proto.school, and there are a lot of tutorials about the IPFS, how it works. It's a JavaScript API, and you can also contribute to IPFS protocol. They are both open source projects. They are on GitHub, and it's really easy to use. So it's time to end, but enter the interplanetary universe today. You can start by installing IPFS Desktop and give your operating system superpowers. And you can also install our extension for Firefox and Chromium-like browsers, which is called IPFS Companion. And that's all.